Hello students, my name is Nagendra Pawan. I am your maths teacher here. So today we are going to see an important concept called completing the square method. So why I am taking this concept is, this is it has varied applications in many chapters. For example, it has application in geometry, it has applications in calculus, integration. So, and this method has been deleted in CBSE. So, but this method is very important. So, we are going to learn about this, completing the square method in quadratic equations. So, completing the square method so let's take an expression, quadratic expression ax square plus bx plus c. So here what we're trying to do this expression is we're going to bring it from a plus b whole square format. So here I'm going to convert this. I'm going to make the coefficient of x square as 1 by taking a as common. So let's do that one. If I take a common, x square plus b by ax plus c by a. So now this the coefficient of x, if you see here, it is b by a. Now I am going to convert into in the format that you get it in. This is a square. If you compare this with a plus b whole square format, so a square plus 2ab plus b square. Already in place of a square you can say x square is there. So a equal to x here we can say. So here in place of b, 2ab, x is already there. So a we already exist as x. So I am going to form 2 into b format. See, let's see how we do it. X square plus 2 into x into b by 2a plus c by a. I hope you are able to understand. See, we just adjusted this in a way that you get 2 into a into b format. So now, if you see, when you compare this to this formula, we have a square, that is x square. We have 2ab, that is 2 into x into b by 2a. So now I am going to add and subtract b by 2a whole square. So we get a into x square plus 2 into x into b by 2a plus b by 2a whole square minus b by 2a whole square plus c by a. So from this we are going to get here, this will be equal to a into x plus b by 2a whole square, right? So this is in the format a square plus 2 into a into b plus b square. So this becomes a plus b whole square, x plus b by 2a whole square. And the remaining part, if you see, it is plus c by a minus b square by 4a square. So this is the completing the square method. So when you equate it to 0, we are going to finally end up with x equal to minus b plus minus root of b square minus 4ac divided by 2a. So this is the quadratic formula, you get it right. So but the origin of this is completing the square method. So now this derivation, like how you are able to make this expression like completing a square, that concept we are going to use in geometry, circles. So now move on to the circles. So what is a circle? Generally, it is a locus of the points which are equidistant from a fixed point. Means all the points, if you collectively take from a fixed point, if they are equidistant, when you combine all the points, you are going to form a circle. For example, so let's start this one, circle. We have a circle here. If there is a center, let's assume that coordinates of center h comma k. So now locus of all the points which are equidistant from this fixed point. So when you join all of them, this forms a circle. So let's assume that the point on the circle is p of x comma y. And the distance between the center and the point, let us assume that is the radius, small r. When you know the coordinates of them, that is root of x2 minus x1 whole square plus y2 minus y1 whole square is equal to the distance. So here x minus h whole square plus y minus k whole square is equal to r. So when you do the completing square on both sides, you are going to get x minus h whole square plus y minus k whole square is equal to r square. So this is the standard equation of a circle. So generally every time you won't be given the standard equation in this way. So they will give a general format of a second degree equation. For example, they will give you like this: x square plus y square plus 2gx plus 2fy plus c equal to 0. Okay. So now they will ask what is the center of this circle, what is the radius of the circle. So how do you do this one? We're going to use the completing the square method in this. See here, now bring the x terms to one side and y terms to this. See, I'm going to segregate them: x square plus 2gx plus y square plus 2fy plus c equal to 0. See, now if you see here, this is already in the format of a square plus 2 into a into b. B square is missing, so I'm going to add and subtract b square, or both sides I'm going to add b square. So we're going to see here, we're going to get x square plus 2 into x into z plus g square. Next, similarly see y square plus 2f into y. If you consider this y square terms, y terms, there is a square, 2 into b. B square is not there, that is f square is not there. So I'm going to add f square on both sides. So y square plus 2 into y into f plus f square plus c equal to, both sides we're going to add g square, right? So we're going to get g square plus f square. So now these three terms and these three terms, when you consider these three terms, it is the format of a square plus 2ab plus b square. So we can write this as x plus g whole square. And these three terms, if you consider, again it is a plus b whole square format. So y plus f whole square. And if you transpose the c to the other side, we're going to get z square plus f square minus c. So now I'm just relating this to this. So if I write this in the format of like x minus of minus g whole square plus y minus of minus f whole square is equal to, if I take root n square of this one, it will become root of g square plus f square minus c to the whole square. Now compare this to h comma k. In place of h comma k, what is the center? Minus g comma minus f. That is minus half of the coefficient of x and minus half of the coefficient of y. And what is the radius you see here? This r. Here the radius became root of g square plus f square minus c. So this is one of the application of completing the square.